Hey, it's Matthew Todd and welcome to Lesson 3 in this module. In this lesson, I want to show you a demonstration of TDD. I want to take a very simple application and show you what adding the first couple of features to this application in a test-driven way would look like. Now I know that some of you may have some experience of TDD already, some more than others, but even with experienced developers, I find when I run this course in person, they always get something out of this. There are always a few surprises for them. I'll show you a fairly purist demonstration of TDD. I think it's useful to show what it would look like in its purest form, and sometimes it is useful to take things at this such a low level of detail, other times not so much, but it's always good to know what it should look like in its pure form, so that when we do take shortcuts and try and do things in slightly bigger chunks, we know exactly why we're doing it. So, with that in mind, the application I want to demonstrate today is one I often use as an exercise, which is the reverse Polish notation calculator. So with a reverse Polish notation calculator, the operator follows the operand. So rather than 1 plus 2 for addition, it would be 1, 2, plus. And as you can see from this demonstration, the calculator is a stack-based one. So we can put multiple values on the stack, like so, and then apply the operators. And we can see the stack is manipulated, values being taken from the stack, and as we perform a calculation, the result of that calculation is then put on top of the stack. So in this example, you can see the top two numbers are taken from the stack, 3 and 2. We perform the add operation, and now we're left with the first value of 1, and the result of that calculation, 5 on the stack. So we've now got two numbers on the stack, and you can see here we can apply another operation again, replacing those numbers with the result of that calculation. If you're on a Mac like I am here, the built-in calculator application has a reverse Polish mode which you can put it into. But there are many calculators you can download or even use online which will let you play around with the reverse Polish notation. The Wikipedia page, as you can see here, also has a good description of what reverse Polish notation is, as well as a table which gives some sample calculations, showing how the stack is manipulated as the operators are applied. Now in this particular video, I'm going to TDD a very basic form of the calculator, initially just supporting the add operation. And in this video, it's going to be in Java. If you prefer JavaScript instead, prefer to see a JavaScript demonstration, then this exact same exercise I've repeated in JavaScript, and you can see that in the additional resources section on this page. So we're going to start with a simple blank Java project, as you can see here. This is a brand new project, following Java standards for the main application code and the test application code, split into main and test directories within source, as you can see. Adding Java directories for the Java code, and then in the IDE I'm just marking each main Java and test Java directory as either a source or test directory, as you can see. So now we've got our standard Java project directory layout set up, we can start thinking about the implementation. So the first thing we're going to do is create a package for our code. In this case we're going to call it Fluent Software. The package structure in the test and main are going to mirror each other. So we've got the same package structure in the application code as the test code. Now we're taking a test-driven approach, so the very first thing we need to do is create a test for a calculator. So we'll create a calculator test class like this. And where do we go from here? Well, again, it's a test-driven approach, so we're going to start with a test. Now, what's the first test that we could create? What's the simplest piece of functionality that our calculator could have? If we think about what our calculator first looks like, a new calculator should have an empty stack. So we know it's stack-based, but a new calculator should have an empty stack. So we'll create a test for this. Test new calculator has empty stack. I'm going to mark it as a test like so, add in the JUnit annotations. We're going to use JUnit 5 in this case, doesn't really matter, the principles are the same no matter what technology you're using. And the first thing we're going to look at doing is creating a new calculator. Now notice we haven't actually created this calculator class itself, so we've got our first failure. We've got our first red phase from the red-green refactor cycle. In this case it happens to be a compilation failure rather than a test failure itself, but we've now got something which we need to correct, which we can correct. So the test is driving this behaviour. The test is forcing us to create this calculator class. So we can fix this quite simply. Create the class, but we're not going to add anything to it yet until our test forces us to do so. So switching back from the calculator to calculator test, this is obviously now compiling, as you can see in the IDE. Now we need to test the calculator has an empty stack. So the first thing we need to do is to retrieve the stack, and that's already forcing us to think about the type of data that we're going to be operating with. In this case, we're going to represent the stack as a list of floats. So we call calculator get stack. Again, this is a compilation failure, so we're going to use our IDE to correct this. And again, we're going to provide the simplest implementation that will cause our test to compile or pass. So that's back to compiling. Now we can add our first assertion. We want to assert that the stack is empty. Now we're in a position where we can run our first test. So running our test, we expect this to fail. And that's good. We want to see the test fail before we see it pass. We're following that red-green cycle. So as expected, the test is failing. Null pointer exception, because our getStack method returns null, and we're attempting to call isEmpty on an instance of this, which is null. So null pointer exception. So again, to make this test pass, we're going to add the simplest implementation possible. Here, just returning an empty array list. Now running our test again, we see that it passes as we expect. So this is our first test. We've already switched between the test and the implementation code a few times, in very, very small iterations, taking a fairly purist approach to TDD, where we even treat the compiler as part of this TDD process, as part of the red-green cycle. So now we've got our first test passing. We've got a very, very small amount of implementation. Let's think about what tests we could add next that's going to allow us to build out our implementation. So, moving on from the empty stack from a new calculator, let's make sure that we can actually push values onto the stack that we can operate with. So the first thing to note, the first piece of behaviour that we care about, that we would expect from a calculator, is when we push a new value onto a stack, we expect the stack size to increase. So adding a test for this, we'll create a new calculator as before, and we'll attempt to push a value onto the stack. So again, we've got a compilation error. We're calling a push method which doesn't exist yet. So we can just use our IDE to give us a default implementation, which is enough to allow us to continue. We're back to compiling, so now let's write some more test code. So we'll retrieve the stack exactly as before. This time we want a different assertion. We want to assert that the stack has a size of 1. So this is compiling, so let's run the test. And the test is failing as we expect because we're just returning an empty array list. Our stack will always have a size of 0 at the moment. So now we can go back to our calculator implementation, and we're going to add just enough code to make this test pass. So in order to proceed, we're going to add a private field for our stack, which we'll instantiate like so. We'll change our getStack method to actually return this private stack field. And now we can look at our push method itself. Notice here we're not actually pushing the value we're passed, we've just got the simplest implementation of push as possible, and we're just pushing a default value. So this might seem like we're being a bit too much of a purist about the TDD approach here, but it does serve a purpose. We're doing enough to make this test pass, and then we're going to add a second test, which is actually going to test the value is correct. And what this does is it means that each test is testing a very specific piece of behaviour. Our intent is very clear from this test, exactly what we expect. So we've done enough to make sure that this test passes. We know that pushing a value onto the stack does increase the stack size. A test passes. So now let's continue with this second test, where we actually test that the value on the stack is the value that we pushed. So in our new test method, instantiate the calculator, push a value onto the stack, but this time our assertion is different than before. Here we're not checking the stack size because we've done that in a different test, but we are actually checking the value at the top of the stack to make sure that it matches the value that we pushed. So running this test, see it fails as we expect. Got a value of 0 on the stack because that's the default value we're pushing at the moment. So now we can switch to our implementation, switch to the calculator class itself, and change it like so. Okay, so now our test is passing. So, what should we look at testing next? Now, whilst not strictly following a TDD approach, we're going to deviate slightly, but here I'm going to create a test for a piece of behaviour that I care about. I know that the implementation is just pushing the value onto a stack. It's a very simple implementation. So I know that pushing multiple values is going to be okay, but this is a behaviour that I care about. This is something that I think is important. I would like to get some confidence that this is going to work. So we're creating a test here where we're pushing 2 values onto the stack, and we're making sure when we get the stack back from the calculator, both of those values are on the stack, and they are there in the right position on the stack. So we'll push 2 values, get the stack, and then we're asserting that both values are on the stack in the right order. And as expected, this test passes. So not strictly following the red-green cycle here, but it is a test that we care about. It is a piece of behaviour that we care about, hence adding this test. And whilst we could have taken an approach that would probably have caused this test to fail first, I think that would have been overly contrived in this case. So we know that our stack behaviour matches our expectations. We can push values onto the stack. Now that we know we have a calculator with a stack of values, let's think about implementing our add operation. So before we jump into the actual calculation, what's the simplest thing that we could say about the add operation? Well, an add operation shouldn't be allowed if the calculator doesn't have enough values on the stack to perform the operation. If we're going to add some numbers together, we need at least 2 numbers to be able to perform that calculation. So let's add a test to ensure that if we attempt the add operation with a new calculator that doesn't have any values on the stack, this operation is not allowed. So here we're instantiating our calculator, and we're adding an assertion to ensure that when calculator add is called, it throws the relevant exception. In this case, an empty stack exception. Now notice we've got a compile error here as before, because the add method doesn't exist. So our first failure. Again, we can use our IDE to auto create a default implementation. Now, running this test, we see this fails as we expect because our add implementation doesn't currently throw an exception under any condition. You can see that from the error message here. So now let's go back to implementation again and add the simplest implementation needed to make this test pass. So here we'll simply throw the exception, and running the test you can see it passes. So onto our next test case, onto our next test method. So we know that add shouldn't be allowed with an empty calculator with nothing on the stack. The add operation also shouldn't be allowed if there's a single value on the stack. As we said before, we need two values to perform this operation. So, much like the test above, instantiate a calculator, make sure it throws the empty stack exception, but in this case we'll push a value onto the stack before we invoke the add. Because we're always throwing the exception, we know this test will pass, but again this is a test case that we care about. This is a piece of behaviour that we care about, so it's important to add a test for it. Now we can move on and think about what happens when we've got two values on the stack and we attempt to perform the add operation. In the same way we tested the stack manipulation before, we can test it again here and add a test case to ensure that when we do perform the add operation with two values on the stack, after performing the operation there should be a single value left on the stack. So the stack size decreases when we perform an operation. So we'll create a calculator. Push two values. Invoke the add operation. And now we'll add an assertion to ensure that the stack size is 1. There's a single item left on the stack. So running this test, we see that it fails as we expect because we're throwing the empty stack exception. So now we're going back to our calculator implementation and we're going to replace the line of code that throws the exception. So here we're going to go with the simplest implementation that will allow our existing tests to pass. So we're going to remove two values from the stack and push another value onto the stack. This will ensure an empty stack exception is thrown if there aren't any values to pop from the stack, and pushing a default value is sufficient to make this test pass because here we're purely testing the stack manipulation, not the actual values on the stack. So with that change, our test is passing and the previous tests are passing as well. So our implementation is purely sufficient to make the test pass. So again, back to our test code, adding a new test case. Now here we can actually make sure that the add operation results in the right calculation being applied. So the result of the calculation is pushed onto the stack. So we'll instantiate the calculator as before, push two values on the stack, invoke the add operation, and this time we're asserting that the result of the calculation is on the stack. We know the stack size is correct, but this time we're going to care about the stack value, which is the result of the add operation. So in this case 6 plus 3 is 9, so the value left on the stack should be 9. Now this test is failing because we're just pushing a default value onto the stack, as you can see here. And now we can switch back to the calculator class again to add the correct implementation, this time performing the add operation itself. So rather than pushing a default value onto the stack after popping the previous two values, we'll push the result of val1 plus val2. Quite a simple change, but again using the TDD approach to do very, very small iterations, switching between test, implementation rapidly until we build up our test cases and have a usable implementation that behaves exactly as we expect. And this is TDD in its pretty pure form. It's a pretty straightforward approach to TDD with a simple application. And there are many different ways this application could have been implemented. A simple calculator could have manipulated the stack in a number of different ways. It's always interesting to see when I do this class in person how many people come up with different implementations. Some people sticking with a stateful implementation of a calculator, some people going with the stateless approach, but it doesn't matter how we implement it, the test-driven approach is always the same. Very, very small iterations, switching between test, implementation, red, green, red, green. So that's it for this lesson. I look forward to seeing you in the next one.